what engineers do. What we are now going to be discussing is what now engineering is about. Now we want now to go to the root of engineering, and we say that engineering comes from the Latin word called ingenia, and this word means to design or to devise. That is where engineering came from. And therefore, that is where engineering rotates. It rotates about designing to devising or making devices. So engineering is a design and a constraint. We are now coming closer to official definition of engineering. We are saying that a general definition is that is a design and a constraint. And we normally design devices, design components, design subsystems or systems such as this one. So we design aeroplanes, engines, air conditioners, heart valves, bridges, prosthetics. This is the components that artificial feet. So artificial feet is made by an engineer. This cannot be made by a layman. So we either have engineers or laymen or technicians. A prosthetics is designed and made by an engineer. Then there are microcontrollers. These are small computers that learn in gadgets. So if you ask ourselves, if you have a radio, is like a typical computer that has some inputs and some outputs. So it gets some input, you tune which station you want to hear, and it gives you some audible sounds. So this is it is learning some microcontrollers inside that receive instructions and gives you some output. So this is a product of an engineer. And again, if you are trying to make things like you want to make robots are going to be made by components like this one. These are the ones that receive instructions. When you give instructions, they learn what you have, what is on the environment, then what steps they should follow when they are performing their task. The components that are inside the robots, one of them is a microcontroller. It's a small computer that runs inside small electronics. And again, as I described, buildings, a skyscraper, a tall building, this cannot be made by a layman. Someone must have gone to school to study the structural designs of such a skyscraper, and therefore that is what engineering do. Heart valve is just an artificial valve that can be put in a heart that can control the flow of blood to and from. Artificially can be put in probably a damaged heart. I think that example would be enough to explain that. And then we are also asking ourselves again, engineering. What is engineering? And we are saying that successful engineering design improves quality of life while working within technical, economic, business, societal, and ethical constraints. So we in our earlier slide, we say that an engineer makes the products under certain constraints. We don't just make products for the sake of making them. So what we do is that we have constraints that we must observe. And the last time I was discussing about constraints, I was saying that you cannot make a bridge. It costs 10 billion Kenya shillings, so to speak, and then you are very proud that you have made the most expensive bridge. There's a constraint because you don't have all the money to make one bridge. So we normally ask ourselves, what is the minimum constraints that we must observe for us to make this beam for supporting a bridge? And therefore, we always work at the constraints, both economical, because they are going to cost money, societal, we want to make sure that people, as they cross this bridge, they are not going to collapse with their vehicles, etc. The business-wise, it doesn't make business sense to make that product. Is it going to allow even the people who are making it make profits or make their business viable, etc.? So we always follow the technical, economic, societal, and other ethical constraints that we are going to be learning about as we learn engineering. So we have, I think I've already said it before in this class, that technology is a product of engineering. So most of the products that we have been highlighting is that when they come from engineering, then we call them technology. So I think that now becomes rather straightforward. So engineering define. Now we want to define engineering now formally, and we want to say that engineering is a profession in which. So this is the one I would like you. If I ask you to define engineering, this is the one that I would like you to give me. That is a profession in which knowledge of maths and natural sciences gained by study, experience, and practice is applied with judgment to develop ways to use economically the materials and forces of nature for the benefit of mankind. That is how a body that accredits engineering internationally called ABET defines engineering. So that is one definition. And the key highlights that I hope you people and anyone who wants to define engineering must observe is that there is a knowledge of engineering involved, knowledge of mathematics and natural sciences. So you must understand mathematics, you must understand science for you to practice as an engineer. Then it is gained by studying. You can't gain it by guesswork or by anything else. So it is gained by studying. Also experience. Over time, as an engineer, you get some experience and by practicing. So you get experience and practice. So we are talking about 3 ways of gaining this knowledge. 1, studying. 2, experiencing and practice. And these are how you gain this knowledge. And lastly, you must apply that knowledge with judgment, because we said you must be accountable. And therefore, in your understanding of what you have learned, you are going to be applying judgment to develop ways in which you are going to make economical things and using the materials and forces that appear in nature. So engineer, like a civil engineer, applies sand, cement. Cement is manufactured, so this is artificial, and then some ballast naturally to make concrete. Okay, to design. So what happens is that every time civil engineers are coming up with better ways of designing concrete that you can withstand different kinds of forces. The combinations that you have had masons, masons are given instructions by engineers. They are told get 3 ratios of ballast and mix with the 3 ratios of sand and 1 ratio of cement to make some concrete, or to make the ground on which factories can be built on. So that is purely how civil engineers come in and assist the masons to make that concrete. Cabros are the small bricks that are put on the floor of the compound. So in viewers, I'm saying that engineers apply some knowledge to come up with such products. So when now they have learned how to make this, to design, I'm talking about design. They design this. They will no longer be making them. They are going to be leaving them now that to masons to do the work. But the work of designing cabros from plastics or these bricks is designed by an engineer. Some knowledge of mathematics and sciences, and with study, practice, they apply some judgment to make products from natural forces, from natural products and others that are man-made, to make products that are beneficial to humanity. So that is one way you can define engineering. And some other ways that you define engineering is that you must always know that it is a profession. It applies maths and natural sciences in the area definition, that we are engineering is a profession first and foremost. It is using the knowledge of mathematics and natural sciences that is gained via experience, study, and practice. And when you say practice, is that you are practicing at a professional guidance. So you may gain experience on your own, but you must also gain the knowledge and practicing under the guidance of an engineer. So that is the difference between practicing and experience. So you work under an engineer, they guide you on how to practice as an engineer and to apply professionalism in your knowledge, and you become an engineer. And lastly, we talk about applying judgment. From the many skills you have gained, you must apply judgment to practice as an engineer. And therefore, we also say that the engineer is normally constrained by a number of factors, such as economic, materials, among others, and we have already mentioned them. And the end product is for the benefit of mankind. So when we are not saying that you are just observing things like scientists do, but you are making things for the benefit of mankind. So again, you're not applying trial and error or guesswork. You are applying knowledge that you have gained to practice as an engineer. So we are saying that engineering involves all these aspects, and they are very important in our practice. So I think I stop there for now.